Okay, CP, CTC. So our common core really is going to be G for geometry, CO for congruence, and it's number 10, which is basically proving theorems about triangles, okay? Okay, proving theorems about triangles. So, here's a proof. One of the things we should always do when we do a proof is mark our figure with the given information, okay? Always mark your figure, okay? Because then you get a visual. And then look for keywords, okay? I don't see any keywords in this one. Keywords would be like bisect or midpoint, things like that. There's no keywords, but there's definitely things to mark. So if I take a look at it in my given, I've got AB, that's right there, congruent to DC, okay? I'm going to mark it. I like to mark my figure because I get a visual, okay? And ABC, angle ABC, that's this full angle, is congruent to angle DCB, that's that full angle, okay? I'm going to prove angle A is congruent to angle D, but before I do that, I'm going to have to prove some triangles, okay? So I think the triangles I'm going to look at has to be this big one here, okay? And the other one has to be this triangle here, okay? So somehow, right down here, I'm going to have to prove ABC, triangle ABC is congruent, change that to congruent, to triangle DCB, okay? Alright, so you cannot say A is congruent to D until you prove the triangles are congruent, okay? You have to say it. So right off the bat, step one's easy, right? Everybody agree with that? Step one, AB congruent to DC, and we've got angle ABC is congruent to angle DCB by given, right? Nobody should ever miss the first step. If you miss the first step, I don't know where you've been for the last couple of months, right? Been sleeping, huh? For a whole couple of months. Okay, good. So now, step two, we've got this reflexive. Now if I look at both triangles do share something, don't they? What do they share, Kurt?
BC.
They both share DC. So if BC is equal to BC, it's saying that, you know, that side's equal to the other side of the other triangle. So we're going to say BC is congruent to CB. And I'm going to mark it, all right? Mark that. Okay. So I have three things. Remember, we've got to have two pairs. I've got to have sides going to sides or angles. So I have the three things, so I can say the triangles are congruent. So let's see what I got. I've got a side angle side to a side angle side. So I'm going to say that triangle ABC is congruent to angle DCB by side angle side. Now, because the triangles are congruent, I can say anything I want about their corresponding parts, right? So A's got to be congruent to D because they are corresponding parts of congruent triangles, right? They are corresponding parts of congruent triangles. CP, CTC. Corresponding parts of congruent triangles are congruent. Thumbs up. Sideways. Not so good. Emma's got a wavering up, right? Okay, good. You guys are starting to get the hang of proofs, aren't you? Told you it'd take a couple of months. Said, you know, you're going to be in the fog and eventually it's going to clear. Okay, let's take a look at number two. Okay, so again, when I do a proof, I look at the keywords. I try and mark my figure. I don't see any keywords, but I do see some things about parallel, and I see some congruent lines. So let's go ahead and mark it. So for me, parallel, if EG, that's this line, is parallel to DF. So these two lines are parallel, okay? And I've got EG, side EG, is congruent to side DF. Okay, so let's mark it. Step one, let's put in our given, right? EG parallel to DF, and EG is congruent to DF. Given, right? Alright, step two. EGD. EGD, this angle is congruent to angle EDG. Hold on. EGD. EGD. F. It helps if I can see F. G. There you go. That one. Okay. Anybody? Anybody? Yeah, you guys agree? Do you see the Z? Do you see the Z? Because the parallel lines. So the big key was parallel lines, right? If you had the parallel lines, you had to have either one or two things. Either you're going to say alternate interior angles or corresponding angles, but I see the Z. Nice job, Katie, so I agree. AIA, alternate interior angles. Okay, reflexive. What do they share?
Line GD.
Right? So let's go GD is congruent to DG. So GD is congruent to DG, and that's got to be reflexive. Good. Let me mark that. All right. I have three things, don't I? So if we've got the three things, let's say the triangles are congruent by one of those five, right? So we've got triangle EGD is congruent to triangle FDG by what reason? Let's see, we've got a side angle side to a side angle side, right? SAS. Okay, now all of a sudden we're going to say that angle EDG, we're going to say that this angle, now we're going to just say it, we're going to say, okay, wait a minute, this angle here has got to be congruent to this angle, okay? Why?
CPCTC.
Yeah, once you get the two triangles congruent, you can say anything about them, right? You can say, well, okay, that angle's got to be equal to that angle because the two triangles are congruent, because the two triangles are congruent, all their corresponding parts are. So it's by corresponding parts of congruent triangles are congruent. CPCTC. Okay, now what are we trying to prove? Trying to prove that these two lines are parallel, that ED is parallel to GF. All right, well, let's think about that. So if these two angles are equal, doesn't it force these lines to be parallel? It really does, doesn't it? And that was a converse. What? What are these angles? See the Z? Converse AIA. Converse. So if the alternate interior angles are congruent, it forces lines to be parallel. Does that make sense? Okay. Capiche? Thumbs up. Sideways. Down. Okay, good. Great. Turn the page. Another proof. Aren't we so lucky to have proofs, huh? Yes. Well, if they do throw a proof on the state test, it will be a triangle proof. That's why I keep going over. Okay, that's what they will do. It'll be a triangle proof. So, right off the bat, again, two things that I do. One is I mark my figure with a given, and two, I look for keywords. This one I've got a keyword. I'm going to highlight the keyword midpoint, okay? The whole idea about a midpoint is going to be in the middle, right? Okay. So, midpoint. So first of all, right off the bat, let's do this. G is the midpoint of FH. Let's go ahead and write that down. My given G, midpoint FH. And I'm going to write EF is congruent to EH, okay? Given, right? All right, now let's mark my figure so I do know that I can mark EF is congruent to EH. Okay, I got that, all right? So, I need three things. I've got one. I got one. Let's get three. So, FG and GH. So why is this side equal to this side? Nice job, Kurt. You guys agree? It's a midpoint, so definition of midpoint or midpoint, there is no such thing as a midpoint theorem, but if you just write midpoint, you're going to get it, okay? Midpoint theorem. Definition, it is really definition of a midpoint. You don't have to have these exact, but the word midpoint's got to be in there, right? Okay. Okay, good. We got two things. We need a third thing. So now all of a sudden I've got EG, and GE. Okay, well, it equals itself. What's that? Everybody agree? Reflexive. Let me mark that one. It's getting pretty easy. You guys could have done this one on your own, couldn't you? Probably. Okay. All of a sudden the triangles are congruent. Why?
SSS.
Everybody agree? Side, side, side to side, side, side. Everybody agree? Okay. Yep. Side, side, side. SSS. Nice job, Katie. Now finally then, if the triangles are congruent, then all their corresponding parts are congruent, so we can go straight to Angle 1 is congruent to angle 2. The reason? Corresponding parts of congruent triangles are congruent. CP, CTC. Nice job, you guys. Okay, good. All right, not too bad. So homework, page 262, 3, 4, 7, 8, 9, 17, and 18. All right?